Let's dive into a real medical mystery. It's a paradox that's been puzzling doctors for years, and it's all about one of our most important cancer screenings. This is the story of a hidden culprit, a test that gives a false sense of security, and the incredible detective work that finally cracked the case.
Okay, so let's get right to the heart of it with the one question that drives this whole thing. Imagine you do everything you're supposed to do. You get your screening colonoscopy, and the doctor tells you, everything looks great, see you in 10 years. But then, a cancer diagnosis comes anyway. How on earth is that possible?
To even begin to solve this puzzle, we have to know exactly what we're talking about. See, this isn't just any old cancer. It actually has a very specific name and a very specific definition.
The official term for this is post-colonoscopy colorectal cancer, or PCRC for short, and the definition is right there in the name. It's a cancer that pops up after a colonoscopy came back clean. It's the ultimate medical contradiction. The disease appears right after the test that's supposed to prevent it.
And for a long time, the conventional wisdom was pretty simple. These cases were just seen as a failure of the screening itself. The main theory was, well, the doctor must have just missed something. A tiny lesion, or maybe they didn't get all of a polyp. But as we're about to find out, the real story is a whole lot more fascinating than just simple human error.
So let's look at the first set of clues. Researchers started comparing these so-called missed cancers to the regular run-of-the-mill ones to see if there was something fundamentally different about them.
And right away, some really interesting patterns started to jump out from a huge analysis of the data. First, patients with these post-colonoscopy cancers tended to be a bit older. But here's the kicker. Look at the location. These cancers were more than twice as likely to show up in the proximal or the upper part of the colon. And that's a much trickier area for a doctor to get a good look at.
Now, this was a huge deal, because if these were just random misses, they'd be scattered all over the colon, right? But they weren't. The fact that they were clustering in this one specific hard-to-see area, well, that suggested we weren't just dealing with operator error. We might be looking at a completely different kind of cancer.
And this is where the real-life CSI stuff begins. To see if their hunch was right, scientists decided to go deeper, to look for a unique molecular fingerprint that could set these cancers apart at the genetic level. So they took thousands of tumor samples and started analyzing them, comparing the genetic markers of these mysterious cancers against the regular ones. They were basically on the hunt for a consistent pattern, a signature that would explain why these things were so sneaky.
And guess what? They found it. The first part of this fingerprint is something called microsatellite instability, or MSI. These tricky tumors were over 2 times more likely to have it. Now, the easiest way to think about MSI is that the cell's spell checker is completely broken. Without it, mistakes just pile up and up, leading to really rapid, dangerous mutations.
The second clue was just as clear. The very same tumors were also about 2 times more likely to have a high degree of something called SIMP. Now, if MSI is a broken spell checker, you can think of SIMP as a process that goes around putting off switches on all the important genes that are supposed to protect us from cancer in the first place.
And then came the third and final piece of this puzzle. They found these tumors were almost twice as likely to have a mutation in a very specific gene called BRAF, which is a well-known gas pedal for aggressive cancer growth. So here's the critical point. It wasn't just one thing. It was this consistent 3-part molecular signature, the broken spell checker, the off switches, and the gas pedal mutation. This was no coincidence. This was the smoking gun, and it was pointing directly to one very specific biological pathway.
And that biological pathway has a name. This unique signature finally allowed researchers to unmask the true source of these mysterious post-colonoscopy cancers.
So, meet the culprit, the sessile serrated lesion, or SSL. And let me tell you, these are not your typical easy-to-spot polyps. They are the starting point for a very distinct road to cancer, called the serrated pathway, and they are absolute masters of camouflage.
So why are they missed so often? Well, just look. Unlike a normal polyp that kind of looks like a mushroom on a stalk, these SSLs are often flat with just a subtle sawtooth edge. To make matters worse, they're often covered in a thin layer of mucus that helps them blend right in with the colon wall. And remember, they love to hang out in that hard-to-see upper colon. They are basically biologically designed to be overlooked.
And this is how all those molecular clues we just saw fit together perfectly. It all starts with that BRF mutation, the gas pedal. That kicks off the widespread SIMP, which silences all the protective genes. With the defenses down, the DNA repair system fails, which leads to that MSI. And that whole cascade flows directly into cancer. It's a clear, step-by-step process that starts with these sneaky little lesions.
So solving this mystery is more than just a cool piece of science. It has some really profound implications for how we need to think about colorectal cancer screening going forward. Honestly, the study authors themselves put it perfectly. They said the key to making screening better is to get way better at spotting these specific serrated lesions. The goal is no longer just about doing a colonoscopy, it's about getting much better at finding this one particular bad guy.
And that's really the big takeaway here. It's a fundamental shift in focus. It's about quality over just quantity. In fact, a new standard for a good colonoscopy is emerging, the sessile serrated lesion detection rate. It's all about training doctors to specifically hunt for these camouflaged growths.
And remember, these conclusions aren't just based on a handful of cases. This was a meta-analysis that looked at data from almost 21,000 patients. That gives these findings an incredible amount of weight, and it makes the call to action that much more urgent.
And that really leaves us with a totally new way of thinking about this. For decades, the big question was just, did you get the test done? But now the real question is, how well are we actually looking? The future of great screening isn't just about the procedure anymore. It's about perception, about mastering the art of seeing what's been hiding in plain sight this whole time. Thanks for listening.